Hey guys, welcome to section 3.4. This section is going to focus on equivalent statements. There's actually going to be three topics that are covered in this section: equivalent statements, followed by De Morgan's Law, and variations of the conditional statements. The last two, De Morgan's Law and variations, get pretty technical. I would probably jot down those alternate versions of conditional statements and keep them in a notebook rather than trying to memorize them. Okay, in order for two statements to be considered equivalent, both of the statements have to have exactly the same meaning. So that means when you develop their truth table, all their truth values need to be exactly the same in the truth columns. If they are equivalent, they'll use the special double bar arrow between the two statements, or they can use the triple line. Both of those mean the statements are equivalent to each other. If the answer columns are not identical, then you cannot call the two statements equivalent statements. Sometimes we'll use the words logically equivalent. That means the same thing as equivalent. Okay, so for an example, let's say that statement 1 is P and Q or R, and let's say that statement 2 is P and Q or P and R. We want to show whether these statements are equivalent or not. Okay, so essentially what you're going to have to do is you're going to have to make a truth table for statement 1, you're going to have to make a truth table for statement 2, and then you're going to have to compare them to see if they are logically equivalent. Okay, so let's do that really quick. I'm going to shrink these down a little bit and scoot them up here. We can still see them, but we don't need them that big. Okay, so let's make our truth table for statement 1. Okay, so in statement 1, we have P, Q, and R. So we're going to need 8 rows for that. Okay, so the P will just be 4 trues, followed by 4 falses. The Q is going to be 2 trues and 2 falses, 2 trues and 2 falses. And then the R will be every other one. True, false, true, false, true, false, true, false. Okay, so in order to do this, we're first going to have to find the truth value of Q or R. And then once we have that found out, then we can do the truth value of P and Q or R. And that will be our truth statement for our truth value for our first statement. Okay, so remember in an or situation, as long as one of them is true, you get to mark them down as true. So Q and R, you have true, 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 false, false, true, false, false. So that'll be your first false situation. True, 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 false, false, true, false, false. That'll give you a false situation. Okay. Then we need to do P and Q or R. So we need to look at the P column. We need to look at the column we just created, and we need to do the and with that. And remember, the and is only true if you have a true, true. Okay, so we have true, 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 false. That'll be false. Actually, the rest of them are going to be false because the P is false the rest of the way down. Okay, so these are the truth values for statement 1. Okay, so now we're going to have to do it again for statement 2. So in statement 2, we're going to have to find P and Q. We're going to have to find P and R. And then once we have both of those, we'll have to find the or between P and Q, P and R. Okay, so we'll have an additional 3 columns here. And this or will be our statement 2. Okay, so let's first do P and Q. So remember, when you look at P and Q, the only time it'll be true is if they're both true. So we've got true, 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 false, 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 the rest of the way down. Okay, now look at P and R. True, false, true, false, 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 false. Okay, so now we have to take P and R and P and Q, and we have to do the OR operation between them. So remember, the only time that you get a false on the OR is when they're both false. So true, 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 false, false, true. Okay, and then you're going to get falses all the rest of the way down because we have falses all the rest of the way down for both categories. Okay, so now you need to look at Statement 1's column and Statement 2's column, and you need to compare them. And you notice how they are identical to each other? As long as the two columns are identical, then you can say that the two statements are equivalent to each other. Okay, so here's another scenario. Determine which statement is logically equivalent to, it is not true that the tire is both out of balance and flat. Okay, so if we're going to have to do that, the first thing we'll have to do is we'll have to change everything over into symbolic form, and then we can start dealing with the truth values for each one. Okay, so first thing we'll have to do is translate, it is not true that the tire is both out of balance and flat. Okay, so let's do that. Shrink this down a little bit. Okay, so when we do that, I'm going to let statement P be the statement that the tire is out of balance. And I'm going to let statement Q be that the tire is flat. Okay, so we have to translate it is not true. So remember, something is not true, you do the little tilde for the negation. It is not true that. So that's usually an indicator that you need a big set of parentheses, that there's going to be a whole statement following it. It is not true that the tire is both out of balance and flat. Okay, so that would be P and Q. Okay, so we first want to do the truth table for this statement, and we want to figure out its truth values. Then we can worry about parts A, B, C, and D and see if they're equivalent or not. Okay, so we only have two statements. We have statement P and statement Q. So we're only going to need 4 rows. Okay, so we can start P off with true, true, false, false. And Q will be every other. True, false, true, false. Okay, we're going to have to find P and Q. And then once we have that, we'll need to find the negation of P and Q. And that'll represent our statement that we're comparing everything to. Okay, so P and Q, remember, and is only true if you get 2 trues. So we're going to have a true, false, false, false. Now in our 4th column, we're going to negate that. So that'll end up being false, true, true, true. So this is our magical column that we'll have to compare everything to. Now, for part A, we're going to have to first translate it, and then we can do a little truth table with part A. Okay, so part A says, if the tire is not flat, then the tire is not out of balance. Okay, so notice that that is an if-then statement. Okay, so that's going to be your little conditional arrow. If the tire is not flat, then the tire is not out of balance. Okay, now notice the first thing they want is for the tire to not be flat. So you're first going to have to negate P and say, negate Q. Let me erase that because Q is a flat tire. So we'll first negate Q, and then we want the tire to be not out of balance. Well, being in balance is P, so we'll have to negate P. Okay, so let's negate Q first. So Q is true, false, true, false. So the negation of Q is false, true, false, true. Then we need to negate P. Well, P is true, true, false, false. So the negation of P is false, false, true, true. And then you need to apply the conditional statement. Okay, well, the only time that conditional is false is if you have a situation where it's a true, false. So, because we have false, false, that's true. True, false would be false. False, true is true. And true, true is true. So you want to compare this column, true, false, true, true, to this column, false, true, true, true. And notice how they are not equivalent to each other. So these would be, no, they're not equivalent statements. So for part A, you could say, no, they're not equivalent. Okay? We can do that for all of the statements. Let's just do one more just so that you can see what it looks like. Let's maybe try part B. I want to show you what one does look like. Okay, so let's try B. Part B says the tire is not out of balance or the tire is not flat. Okay, so notice your word or. That's going to be your little upside down V symbol. The tire being in balance is P, but they want the tire not in balance. So that would be a not P. Or the tire is not flat. So not flat would be not Q. So we would need to do not P or not Q. Okay, well, not P we already found out was false, false, true, true. And not Q we already found was false, true, false, true. So let's do the or between those. Remember, the only time the or is false is if both are false. So our very first scenario, we get false, false. Everything else has a true in it somewhere. So we're going to get false with a true all the way down. So not P or not Q is equivalent to the false of P and Q. So this one is good. The first one was bad. Okay. We could do the other two, but they're very, very similar, so I think we're going to just move on. Okay. There are some special rules that can skip you from creating these truth tables every single time because it is very time consuming. So if you notice, we actually just did one of those. There's two special cases of De Morgan's law, and notice that De Morgan always uses a big negation in the front. Okay, so the first De Morgan's law is the negation of P and Q. If you want, you can always do an equivalent statement, which would be the disjunction of not P or not Q. So notice it's almost like distributing the negation sign through and then switching the and to an or. It does work in the opposite. If you have a negation out in the front with an or symbol, you can again like kind of distribute the negation through and make not P, not Q, and then switch the or to an and. If you ever have a situation like that, that's De Morgan's law. You do not need to develop a truth table. You can just automatically switch it because it's a theorem and they proved that it's true, and you can automatically go to the final result or the final equivalence. Okay, so for an example, write a statement that is logically equivalent to, it is not true that tomatoes are poisonous or eating peppers cures the common cold. Okay, so the first thing you're going to have to do is translate it. So let's let P be that tomatoes are poisonous. And let's let Q be that peppers cure the common cold. Okay, so if we were going to translate this, it says, it is not true that. So that's your little negation with your parenthesis because you're going to make a statement after it. It is not true that tomatoes are poisonous, so that would be P. Or peppers cure the common cold, so that would be Q. Okay, well, you should notice, hey, this looks a lot like De Morgan's statement. So according to De Morgan, I can just distribute my little negation on the P and on the Q, and then I can switch my symbol from an or to an and. So now you have to apply that with words, okay? So what you've done is you've done the negation of P. So that would be that tomatoes are not poisonous, and you did the negation of Q. That would be peppers don't cure colds. So you've used De Morgan's law, and they are equivalent statements. You don't have to prove it. You've used it appropriately, and you've saved a bunch of time. There's a bunch of other equivalent statements that you can come across. One is the conditional statement, and sorry, I have it written here incorrectly. The first one that you can run in is if you have if P, then Q. If you would like to write that in a different way, one way that you could write it is to do the negation of P or Q. Those will end up being equivalent statements always, so if you want to just use it, you can. Another rule is if you would like to write P or Q. If you would like to write P or Q, you could go and do the negation of P, if the negation of P, then Q. And those will be equivalent statements to each other, so you could switch them whenever you like. So an example would be, write a conditional statement. So remember, conditional is the if-then statement. Write a conditional statement that is logically equivalent to the Oregon Ducks will win or the Oregon State Beavers will lose. Assume that the negation of winning is losing. Okay, so first thing I would probably do is I would translate the statement that they gave you. Okay, so let's let P be that the Oregon Ducks win. Okay, and let's let Q be that Oregon State Beavers win. Typically like to talk about the positive experience and have the negation be a negative thing, so that's why even though they're talking about the Beavers losing, I'm going to put it in terms of winning. Okay, so the original statement says the Oregon State Ducks will win, so that's P, or the Oregon State Beavers will lose. Well, losing means not winning, so we'll have the Beavers losing being not Q. Okay, so this is your original statement. So we want to write a statement that's equivalent to that by using the conditional statement. Okay, so if you're going to do the conditional, that's the little if-then statement. You always negate the first item you have. So instead of P, we'll have the negation of P. And you always use the second statement that they give you. So in here you have the negation of Q, so that is going to stay. So if you were going to read that out loud, you would say, if the Oregon Ducks lose, then the Beavers will lose. And that is equivalent to the Oregon Ducks will win or the Beavers will lose. Okay, so another thing that you could do, another common rule that is equivalent, is you could do the negation of the conditional statement. So remember, your conditional is if P, then Q. Well, sometimes you want to negate that. The negation of if P, then Q. The equivalent statement to that would be P and the negation of Q. And again, it's a rule that's kind of hard to memorize. So guys, use your notebooks, write it down. I don't expect you to memorize all this stuff, okay? Okay, so here is an example of that situation. Write a statement that is equivalent to, it is false. If you hang the picture, then it will be crooked. Okay, so first let's translate. Okay, so let's have P be hang the picture. And let's have Q be that it's crooked. Okay, now let's translate the original statement. It is false that, so negation, parenthesis. If you hang the picture, if P, then it will be crooked, then Q. Okay, so we want to use the rule that we just learned to write a conditional statement that is equivalent to this. So the rule that we just wrote down said that we need to take P and the negation of Q. Okay, now if you're going to say that in words, P stands for pictures, so when we hang the picture and it is not crooked would be the same thing. Okay, so if we hang the picture and it is not crooked. Okay, there's a couple special types of conditional statements that you need to learn about. They are the converse, the inverse, and the contrapositive, and these are special ways to rearrange statements. It's easier to see on the next slide, so I'm going to click over there. Okay, the first is your normal conditional, if P, then Q. Okay, well, if they ever ask you to do the converse, then that means they want you to write it in the reverse order. If Q, then P. Sometimes they'll ask you to do the inverse. So in the inverse, you use the original order, but you negate everything. If not P, then not Q. And last, they'll ask you to do the contrapositive. In the contrapositive, it's the converse and the inverse combined. You're going to switch the order and negate everything. If not Q, then not P. Okay, so let's look at an example, and we'll go here. Okay, so last example. For the conditional statement, if the song contains sitar music, then the song was written by George Harrison. Write the converse, the inverse, and the contrapositive. Okay, so I will tell you before you do this, you need to translate the original expression or you're going to be all messed up, okay? So the original expression says, if the song has sitar, then the song was written by George Harrison. So let's let P be that the song has sitar. And let's let Q be that the song was written by George Harrison. Okay, so the original statement is an if-then statement, so that's the conditional. And it was if it contains sitar, so if P, then it was written by George, then Q. Okay, so first thing we want to do is we want to write the converse. Okay, well, the converse is just simply going to switch the order. So instead of if P, then Q, it'll be if Q, then P. So if you were going to say that in words, you would say that if the song was written by George, then it contains sitar. Okay, your second option is that you can write the inverse. Well, when you do the inverse, all you do is you negate everything. So instead of P, you do not P, and instead of Q, you do not Q. Okay, so if you were going to say that in words, you would say, if the song does not contain sitar, then it is not written by George. And that's your inverse. And then last but not least, you have your contrapositive. So on the contrapositive, you need to change the order of P and Q, and you need to negate both of them. So you'll have it, if not Q, then not P. Okay, so again, if you were going to say that in words, you would say, if the song is not written by George, then the song does not contain sitar. Okay, guys, good luck on this section's homework.